Alright everybody, in this video I'm going to go through this Asteroids implementation with particular emphasis on coding, on the scripting part of it. I'm not gonna do one of those tutorials that are sort of like recreating a whole game or a whole project sort of like line by line, because those will take potentially like several hours to really do well. Instead, I'm gonna go through this project, as you're seeing it, so essentially already like put together and already essentially functioning, focusing instead on the patterns that I'm using to implement this. So obviously, what we are talking about is one of the many possible, infinite possible implementation of Asteroids. The features are not even the entire game as it was, like the arcade in the 70s. And a lot of what I'm doing here is also finalized to be like, it's also really meant to be educational primarily, and meant to be like very clear to understand. So I'm sort of like sometimes using rather inefficient strategies or inefficient sort of like things, just because they are a little bit more readable, especially for a beginner. Let's look at the game, or the structure, I guess like the skeleton of the game as it is now, and sort of like recapping what the features are. By hitting play, you will get to play. The controls are WASD plus space. I think it should be, I haven't tried it, but it should be also controller friendly. You can also use the arrow keys and the space to shoot. But basically works like this. You turn left and right to rotate the spaceship. It rotates in a kind of like an analog type of way, sort of like an emulated analog way. You press up to push the spaceship forward in relationship to its direction. And then you press space or mouse click to shoot. So it's like you're shooting a bullet. When the bullet hits an asteroid, the asteroid splits in two, and then it splits in two again, or actually it's just two passages, but yeah, I kind of forgot. And then both asteroids and the spaceship sort of like wrap around the screen, so they're sort of like teleport in the on the other side. Same thing for the vertical component. And when the spaceship is hit, you lose one life. When all lives are lost, like the indicator here is a bit small, but it says 2. Then when all lives are lost, there is a game over screen, and it's sort of like stop the game, and then you press enter, and it basically restarts the whole game by reloading the entire scene. There is no winning condition, but there is sort of like a basic wave dynamic, meaning that if I destroy all the asteroids, I hope it's not too loud. It's very loud in my speakers, but let's see. So now, as soon as I destroy this one, I will have another wave with one extra asteroid. So that's pretty much it. So this is really a skeleton of a game that goes on forever. Let's look at how it is structured. I already sort of like talked about in the other video about how the project looks like from the editor perspective, but we are going to focus a little bit more on the code. So the one thing about Unity and programming is that, well, Unity uses C#, and C# is, very modern, very high-level kind of program language that looks a little bit like C or C++, and really is not that different from JavaScript in terms of syntax. It has that sort of like parentheses and semicolon and so on, that kind of like very clear, very distinctive sort of like type of syntax as like the biggest kind of family of programming languages. Sometimes I think people refer to programming in Unity as scripting because you're actually creating scripts, so like pieces of programs that are being inserted in a bigger project, and they are interacting with components that already have essentially their own code in them. So there's no like hard difference between scripting and programming, but when we talk about scripts, we generally mean little chunks of programs that are combined with maybe like a bigger engine that we treat essentially as a black box. So one basic setup that I want you to be doing is going to basically the preferences. So preferences, edit preferences. These are the Unity preferences. They're not depending on the project. They are dependent on your installation of Unity. And I would like you to make sure that you have external tools and you have an external script editor that is functioning. I'm currently using Microsoft Visual Studio 2017. I guess I also have the 2019. I don't know why I'm not using that. But anyway, that Visual Studio should be installed, or you have the option to install it with your Unity installation. So if you don't have it open there, like if you don't have it functional yet, maybe you forgot to install it, and that's something you can fix pretty easily. So when you choose installing the new editor, you can install it, and there should be here already sort of like the option. If you don't have the Microsoft Visual Studio Community install, you can install it from there. Some of you might already have a favored programming editor, like you might want to use maybe Eclipse, or I don't know what else. So you can choose it from here. So if you know what you're doing, you can essentially choose your favorite code editor. The most important thing that I want to stress is that the editor needs to be able to understand the Unity APIs. APIs are the application programming interface, basically the functions that are specific of Unity. By understanding it, this is what I mean. If you're typing something like game, for example, you should see a code autocompletion here that gives you like things like game object, which is a very specific Unity thing. So you're clicking game object, and when you're pressing the dot, you should have this kind of code snippets, this kind of like information, and this kind of like basically like helpers, because or like when you are I don't know, say that you have like load scene, or actually let's do something like like an instantiate, for example. Instantiate. So this is another Unity function. So when you have an instantiate, you have a code completion that tells you, okay, what this thing does, and it shows you also the 10 possible parameters you can have. I specifically look for instantiate because that can be used in many different ways. You can create a new object dynamically, but you can also create it by providing a position, a rotation, or a parent, or like there are all sort of like different options, and this is super important. Like you are not going to learn all the Unity programs or all the Unity commands by heart, or at least not immediately. And also like doing things like instantiate Unity. Also doing something like this every time, just kind of like checking the documentation every single time might be like a bit of a pain. So you definitely want to have that set up. How do you set it up? Well, if you're using Microsoft Visual Studio and if it's installed with the Unity installation, you should have already all the extensions you need. And that's why I'm sort of like recommending Visual Studio for that. If you're using some other code editor, make sure that you are installing the extensions that are able to sort of like read what the sort of like the Unity APIs are. So it's not just about the code highlighting, you know, like the colors and the syntax stuff, because like if I forget you know, if I forget a parenthesis, it will also tell me, oh wait, there's something wrong here. There's a parenthesis has not been closed or something like that. You know, like very basic syntax errors should be automatically detected and highlighted. But also, like, you should be able to have like more Unity specific helpers. The other thing that I want you to be able to do is this, like when you're let's close let's close my studio completely. Today it's a bit slow, but let's say that you have a script here. You want to be in a situation that you double click your script and it opens your code editor of choice. In my case, I'm fine with 2017. And open the whole solution. So it should not just open one script, but also the entire sort of like solution structure. That's kind of what you want. That means that your code editor understands that there is a whole world, a whole set of interrelated classes, and so on. I think I actually don't need that part. All right, so let's get into the structure itself and some of the highlight in terms of like pattern, how you go about implementing something like a simple Asteroids. First, one thing you will see is that, well, I will probably start from the player. So the player has a player script which has all the controls, basically the physics of the spaceships, and some stuff about the sounds as well. You could potentially have sounds all controlled externally from an external sort of like sound manager, but I think it might be more, it might make more sense to have the sound that sort of like is produced by this object specifically, so you have an audio source attached to the object, because in a case of more like immersive type of games, it makes sense to have a sound source that is localized and attached to the object that makes the sound. In this case, it's a 2D, you know, arcade, non-spatialized game, so it doesn't matter, but in my case, I have the audio there. So like the structure here is that you have I have a game manager, which is basically taking care of the main loop, turning on the interface, the game over screen, and the sort of like the checking the winning and losing condition, and the player that is its own independent sort of like functioning script for control of the players. And then I have asteroids that are being created, and that are being created dynamically, and they have their own script, asteroid.script, and they are created from prefabs. So I have a prefab here of the asteroid and a prefab of the bullet. These are basically the cookie cutter, the classes that will get instantiated and cloned, and the bullet itself also has a little script. So the scripts, at the end of the day, it's not a lot of code. If you ignore all the comments, I put way too many comments, but like if you sort of like ignore all the green comments, it's not many lines of code. So let's start from the player itself. So the main stuff of the player, Unity works this way. You got some function like awake and start. Awake happens before start. There are like some slight differences, but you can usually use them interchangeably. But basically, you have the first function that gets called as soon as the object is created or as soon as the scene starts with the object in it. So awake basically gets executed once, so you can put all the stuff that involves basically initialization that needs to be done once at the beginning, like a setup of something. and then update is the function that happens every frame. The frame can be an interesting concept in Unity because it's not necessarily 60 frames per second. It's typically that's what it is, but it can be a variable frame rate. But consider this basically this function happening continuously as many times as the engine allows you to. So this is the update, and this is where I do the more like the input polling, sort of like reading the input and applying the forces and so on. So one thing about this is a pattern that I use all the time, especially when I provide templates to students. Often you have the situation that you need, like a lot of what you end up doing in Unity is referencing a component, saving a component in a variable, and then accessing the component's methods or the component's variables. Like in this case, engine audio source.clip equals that is equivalent to opening the selecting this player and sort of like going to this audio source here and putting an audio clip here. So a lot of what you end up doing in Unity is basically like automating or proceduralizing this particular operations that you can also do on the inspector. Sort of like changing this force or changing the position, except you're doing it with code in a continuous way. So in order to do so, it makes sense to reference your component in variables. Referencing just means store them in a variable or cache them in a variable. So if you want to access something like the rigid body, which is what allows you to apply a force to your spaceship and move it, you can access it by using the game object get component or just get component rigid body 2D. But a good practice is just to save it into a variable that in this case I save as RB, so I don't have to use get component rigid body blah 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 and this kind of like awkward access component access every time I need to use it to use a rigid body. So you will see that if I highlight the rigid body, I kind of like apply a torque here, apply a force, apply sort of like clamp the velocity. So I use the rigid body many times, so it makes sense to save it as global variables here. I mean, it's global in the sense that it's seen by the player. Another advantage of having this sort of rigid body structure here, or like sort of like the rigid body referenced as a variable, is that in this case I'm sort of like accessing the rigid body attached to this player only if the field rigid body, we are talking about this field here, only if the field here is null. So if it's not specified, then I will search for a rigid body attached to this object, which should be this one here. You can also, there can be a situation in which maybe your player is composed by different, I don't know, maybe there is like a 3D renderer or something, or I don't know, maybe the rigid body is not attached to this thing. Maybe you have a container that is outside it. And so you can ideally just drag and drop your rigid body that might be somewhere else into this field. You can also drag and drop it from here. So that's the meaning of this sort of like if rigid body is not specified, just to allow you a little bit more flexibility to just plug in whatever rigid body you want. And you will see basically this pattern here all the time. The sprite render, you might have a situation that maybe the sprite render is not attached to this particular game object. Maybe it's like a child game object that has a sprite render. In that case, you can sort of like drag and drop it in this one. Anyway, so that is kind of like what I do. Another thing that I do all the time is referencing the game manager or a main code. This is an interesting sort of like philosophical question that you will stumble upon every time. basically like what should be done, what kind of operation should be done in a centralized way, and what kind of operation makes sense to do within the object itself. For example, I decided that the bullet force will be just generated by the bullet itself. So when the bullet is created, the first thing that happens, I apply a force. This could be this is questionable. It can happen this way, but I can also apply the force from the spaceship, or I could even have basically no scripts whatsoever and have one entire script and basically like administer everything and manage everything from a centralized script. So in this case, one of the reasons why I wanted to sort of like decentralize some of the programming, especially the behavior of the players, is to maybe predispose the game for a multiplayer kind of situation. Now, it's not that you can easily implement, like, you know, with one click implement a multiplayer, but the way I sort of like set it up, you can basically do something like this. I basically duplicated the player, and you can hit play, and you will see that without any issue, you should have two spaceships that are essentially moving independently. I mean, they are all responding to the same control. So they are kind of like moving in parallel, some kind of like experimental indie game, but they are like kind of like independently and kind of like working more or less, except for I guess this restarting point. But it's already essentially predisposed to be potentially multiplayer if you want it to be, and that's just like I think a good indication of the modularity of your code. So it makes sense to me to have certain, like the control system to be arranged and organized from the player perspective, and so everything happens within the player. I could potentially even like get rid of the main game script, and I think the player should work. I can basically like reuse this code and drag and drop this player script, and with basically changing just a couple of lines of code, I can reuse it in a different game. However, it makes sense to have like a centralized script, which is the one that takes care of the restart and the game over, the scoring, and so on. In order for these two scripts to communicate with each other, the easiest way, I think the most straightforward way, is to have a reference to the script, and this is what you're seeing here in the game manager find object of type game. It means that the first thing the spaceship does is looking for something called game. Actually, not something called game, but some game object that has the game.cs script attached. In my case, it will be the game manager. So this is one way to just do this reference that is a little bit more flexible, because I could potentially change the name. I can call it game manager too. It will be found. Might be an issue if I have multiple game scripts. In this case, we'll probably find the first one. But anyway, so now I have a variable here called game manager that is basically a reference to this game object here and the script game. That means that by pointing at this game manager reference, I can do things like communicating that the player is dead, and so be like, or I think I have maybe like a scoring one. I think it's probably in the Asteroids. So in this case, whenever the spaceship collides with the asteroid, it will call a function within game manager. So game manager player death this. So it's passing as a parameter, is passing this player class, or this player instance, I guess. So let's see what the game manager player death is a function here, a public method. It has to be public to be visible from other scripts, and it's this one here. And the comment says called by the player. It expects a player instance. This is again like I'm sort of like implementing this with an eye for a potential multiplayer that could be implemented. So like it tells you, okay, one player is dead, and which player it was that is the one that is passed in the parameter. So again, in order to be visible and called, like there are two conditions that in order to call a function from a script to another script. One is that you need to access the object and the script, in this case game manager is this. And the other thing is that the function, like the method, this function here has to be public, as well as the variable. If you want to change a variable like the score from the player, you can do it, but it has to be public as well. So in this case, I could do like game manager score minus 100. In that case, I would subtract 100 points every time the player dies. So this is kind of like how a lot of things work. It seems a bit awkward to communicate between scripts, but you will get used to it. It's kind of like necessary. Ideally, you want your code to be as modular as possible, so you want things to be self-contained, so you can reuse certain script. But in practice, it just makes sense to have objects talking to each other. All right. Anyway, long tangent, but very important. I'm not gonna talk too much about the sound stuff, but let's get into the fun stuff, which is the controls. So this is how one way you can handle input with Unity. So, and this is kind of like the way I prefer it. There is a class in Unity called input that has all sort of fun options. Let's do like input. For example, you can check if a key is down. You can check if an axis is accessed. You can sort of like read the content of an axis, or you can look for a button. To me, the most flexible way is to use axis and button. So the button is more of an abstraction. It's not necessarily a keyboard key, but it's something that can be both triggered by a controller and by a keyboard. So it can have like both at the same time happening. And same thing for the axis. So this kind of controls, and I'm saying this in as opposed to get key down. So if you go to game CS, like one of the first functions you find is the update function, which reads the input for return, which is enter. So this declaration here, this check here, is much less flexible because it assumes that you have a keyboard, and this keyboard has a return, and this return is accessible to the application essentially, which could be problematic if you want to, for example, port this game to say like PlayStation or Switch. There will not be something called key code return because the Switch doesn't have a keyboard. Or if you are building this game for for mobile or for even like web, the return, the enter key might not be exactly accessible or might be awkward to use. So this is a less optimal way to map a control. I kind of like decided to leave it here so you know it exists. It's a thing you can do. But probably the best way would be to use button down, because the button can be many different things. So when I say horizontal input get axis, I'm reading this horizontal axis variable that is something here that corresponds to the string horizontal. What is that? If you go to if you open the project settings, you will find this reloading script assembly is way too slow. I probably should restart my system to make it a bit faster. But anyway, if you go to window, edit project settings. So these are the settings of the project itself. so not of Unity. You can go to the input manager and you can expand this axis here. This is the old so-called old input system, because the new input system is a little bit more modern and flexible, but also difficult to use. So I will not recommend you to switch to the new input system. So anyway, input manager here, axis. This is the weird way that Unity calls all sort of things, like horizontal axis, vertical axis, fire is an axis, because I think they want to convey the idea that it can be analog type of input. They're not just a button that is just either press or not press, but it can be an analog stick, like the dual stick controller, like a PlayStation or a Switch. So in this case, you have axis, and these things have names. And this name, like for example, horizontal, that's the name. And that's this actual string that you can use and reference in here when you're reading the get axis. This basically expects whatever name you have set up. If you're calling, if you have a second player and have like a second horizontal 2 or something like that, you will have to reference and update that string as well. I'm reading a constant call horizontal axis here, so you can basically like click on the player and configure your controls from the inspector, as opposed to hard code it into the code itself. So you don't have to change the code. Potentially you can reconfigure your control system by just typing things in the inspector here. Anyway, this is what is happening. Input get axis is basically taking a value that, if I remember correctly, is between -1 and +1, including all the 0.5 or whatever, including all the decimals, because consider it as the amount of like an analog axis, an analog stick, the amount of sort of like twisting of the analog stick. So same thing for the vertical input. So I'm operating in an analog way, even though the game doesn't really require that, but I think it's a good way to get used to that. So what I'm doing here is basically I'm reading this horizontal input, so left and right, the amount of left and right, and I'm multiplying it by the rotation speed. The rotation speed is just a variable here. It's a public variable, so it is a variable that I can configure by just accessing the player and changing it from here, from the script. So the rotation, if your spaceship rotates too slowly, you can just change this number and make it, more responsive or whatever. This number here is just a magic number that I calibrated based on all sort of things. So like I just like, when it felt right, I just decided that, okay, 200 seems to be the right number. So the 200 doesn't really represent anything. Horizontal input has a minus just because that's kind of like how it played out. If you want to, turn horizontal, clockwise, you turn right, and that's just like the way the sprite is oriented. And then super important thing, the time dot delta time. You will see it here, you will see it here as well. So the time dot delta time is a representation of the time that passed since the last update. So the game will work probably decently well even without it, but whenever it comes to physics, a transformation like adding a force continuously at every update cycle, you want to multiply your forces by the time delta time to make it frame rate independent. Otherwise, you might have situations in which you have a lot of objects on screen, your frame rate drops, and if your frame rate drops, it means that the update function gets called less frequently than 60 frames per second. Maybe it gets called like 30 frames per second, and that means that some of the logic in your game starts to become inconsistent because your spaceship might move way too fast, or you might you might have a character that jumps way too high because your jetpack has not been jetpack add force has not been multiplied by the time delta of time. So this is super important. You might encounter some serious issues if you have functions in the update function that are not being multiplied by time delta of time. So as a general rule, every time you have add force, add torque, or anything that involves the rigid body, you want to multiply by that function. But it's not a function, it's just like a number, which is like a number in seconds. It's going to be like something like 0.02 or something. So this is just in case you were wondering what the hell is this time delta time. Just imagine it is something that adjust your forces to make them frame rate independent, and it's a very common, very important pattern in all sort of like physics-based games or action-based games. Here I have I'm adding a force. So torque is basically the angular force, right? It's what turns things around their pivot, really. This is kind of what it works. So if you're like turning left, if your like controller is like pushing left, or you're pressing the left key, it will be positive, and so it will just turn one way or the other. Here vertical input is basically adding a force, and here I'm doing a similar kind of transformation. So add force expect, so add torque expect basically a number, a float really, because that's the angular sort of like that's one way you can use it. If you're working with a rigid body 2D, there is only one way you can really turn, one axis you can turn. If you are working in 3D, it gets a little bit more complicated because rotation in 3D can be on different axes. But in this case, add torque on a 2D rigid body will only require a number. In the case of force, you will need a vector, and maybe I should just like refresh what a vector is, especially in the world of video games. All right, I pulled out a little classic representation of a force vector. I could spend the whole semester talking about vectors and vector operations. It can get pretty complicated, but in this case, this is a very simple concept. Say that your spaceship you want to move your spaceship along this direction here. In a typical orthogonal Cartesian world of games, you typically need to provide the two components of this force. So these two components are basically the component on the x-axis and the vertical y-axis. So any sort of like direction or force can be represented through a vector, which is basically a variable that contains two variables inside it, like two components, x and y. And this is basically like, imagine like one person is pulling a rope this way, and another person that is much stronger is pulling the rope this way, and the resulting, and both the rope are attached to, like some weight here, the resultant of the force will sort of like move this way. So that's kind of like what happens here essentially. In order to add a force, I need the x and the y component. And the x and the y component in my case will be related to the direction of the spaceship. So in this case, the up direction. So I always want to move my spaceship according to wherever the spaceship is rotated. So this is a particular kind of movement that is relative to the spaceship direction. Let me put it global. Okay, so this sort of like green arrow, that's the direction that I want. So I don't need to figure out what the vector is because I already have it, because it's just the direction of the spaceship, and it's specifically the direction going up. And that's purely because my spaceship it has been drawn pointing up. If my sprite was just facing right, I will be using this direction just to make sure that the player understands where they are going. So transform.up is just the vertical component of the transform and corresponds to this green arrow. If I wanted, if my spaceship was drawn facing right, I think there's a transform right that will allow me to do essentially the same thing but pointing right. Way too much time just to see like the most underwhelming thing. Like, yeah, so you don't see it, you don't see now, but yeah, it was basically working the same way. But okay. So anyway, so up component, so essentially move the spaceship, like the force will be the vertical component multiplied by whatever I decided that my speed will be. So the thrust speed in this case is really like kind of like the acceleration of my spaceship, and then I'm multiplying it by the vertical input. This could be also not be necessary. In this case, I want to be able to move to essentially use the analog input to potentially like move the spaceship very slowly if I wanted to, and if I had a controller. So this is not a feature of the original Asteroid, because that just used the normal on and off buttons. But just to show you how to use that analog input, is pretty straightforward. The analog input will be either like -1, +1, or 0. So if I'm not touching my controller, this number will be 0, and it will turn this whole force into 0. So I will not be adding any force at all. I will not even get into this F actually. Anyway, so that's the vertical input. Is basically, it's a multiplier depending on how far I'm pushing my analog controller, and then I have the time delta time. So this is basically these two lines of code that are pretty much taking care of all the movement, or most of the movement. Then I have I'm gonna maybe talk about the sound in a second pass. Here, I also want to make sure that I'm limiting the speed and angular velocity, because if you don't do so, you might end up having a very kind of like uncontrollable spaceship, or having to rely too much on physics to limit the speed and turning of your spaceship. So I like to numerically limit both the speed and the torque, not the torque, but the angular velocity of my spaceship. So this is what happens if I don't limit it. I sort of like the spaceship spins out of control. I will also be able to kind of like, accelerate quite a lot potentially. Actually, it's not going that fast. Probably because the friction is also essentially limiting the velocity. But to me, it's a good practice to limit your velocity and angular velocity. And I'm using this vector. I'm using vector 3 magnitude, but I guess vector 2 magnitude will have been also the same, since I'm working in 2 dimension. But clamp magnitude just means take this vector here and limit essentially the length of this arrow. Essentially, that is the magnitude. This like the distance from this point to this point. And same thing for the angular velocity. I'm basically just clamping a number. That means make sure that this number doesn't get less than minus my velocity, my maximum angular velocity, and plus my maximum angular velocity. So like, I don't know, like 30 degrees per second, minus 30 degrees per second, and plus 30 degrees per second. So that's basically it. Here I have, by the way, let me go to, if you go to edit, advanced, and format document, it will do an automatic indentation. So make sure that your code is always clean and readable. Here, I'm doing something more interesting. I'm also using another input function to basically detect when the button is down. Uh, so there are several ways to detect a button or a key. One way is to just detect when the button is down. So if I do something like this, this input, basically this condition will be true every frame as long as the button is currently down. And the result of it is actually very important, very different. So let me show you what happens if I use this different function, which is getButton. I'm going to hit play. Maybe I will restart my computer so there's not so much wait time. But now if I press if I press the button, it will make a terrible sound because I'm playing a million. Let me maybe turn off my audio sources. I'm playing a million sounds at the same time, but also I'm just like sort of like spraying bullets as you know for like 16 times per second or something like that for as long as I press the button down. This could be a feature, could be exactly what you want, but you will probably have to figure out a way to limit the rate of spraying because otherwise the game becomes a little bit too easy. A lot of sounds are playing at the same time. So I'm gonna just use button down because that it means that it kind of like physically limits the amount of bullets that you can shoot, and it has a little bit more of a old-timey arcade feel because in old arcade you often had to mash buttons to perform an action, especially shooting, so it didn't have an auto fire. Anyway, get button down. So if you do get button down, this if will be true, this condition will be true only the frame in which the button went down, and that's why it just plays, it creates one bullet per every time you press. Similarly, get button down up will detect when the button is released and just for the one frame when it happens. Here's another super important thing that happens all the times in games. You want to instantiate an object. You want to create an object out of nothing. Right now in my scene, I have nothing but my player, my canvas that contains the user interface, and you know, just like a special effects explosion, but I don't have any bullets in here, and I don't have any asteroids. In order to create them dynamically, meaning runtime from code, I can use this function called instantiate. Instantiate means create a clone of that particular game object. And as I was anticipating earlier, there can be other different parameters. Basically, you can be like create it at this position, create it with this rotation, and so on. But you can also just pretty much create it at position 0, 0 or whatever. But anyway, instantiate requires a game object as mandatory parameters. When you're basically creating a clone, it wants to know a clone of what. And the most common way to use it is by using a prefab. So you use a prefab. Let's create another a variation of my bullet. Say that I want to create another weapon or something. I'm just gonna create a 2D object that is a sprite, and I'm gonna create like a circle, and let's create like a giant bomb of some sort, or like I don't know, some kind of like weapon. I have a circle here. I can add a rigid body 2D if I want it to exist in this sort of like world, and yeah, actually let's do something ridiculous like maybe using gravity. I think I have a gravity automass. So maybe oh yeah, gravity scale 1. Actually, I'm not entirely sure this has a graph. Yeah, well, let's see what happens if I just create this thing. So let's say that I have I create a kind of like a prototype of this object, a kind of like a cookie cutter of my object, and it's like this globe, this orb, and I'm gonna call it orb or whatever. And right now I can turn this object, meaning this object here with a sprite render attached, potentially a script attached. Actually, I'm going to attach the screen wrapper, which is a script. The script that sort of like teleports the objects from a part of the screen to another. And now I can create a prefab out of this object that exists in the scene. So I grab this thing and I drag it in the asset in the empty space. Try to not drag it on some other prefab because that will overwrite the current prefab. So you drag it here. You can call it orb, or I prefer to call it orb prefab, so I remember that is a prefab. And a few things happen now. Then now I have a clonable object, so I can sort of like create multiple versions of this prefab. I can also create variations of this prefab, but also I have a prefab here, meaning that I can, if I decide that I actually don't like the circle, but I want maybe like, I don't know, like a capsule. If I want a capsule, I can sort of like double click on the prefab, enter this sort of like isolation mode in which I only see the prefab, and then I change things, and those changes will reflect to all the prefab, and now I have a whole bunch of capsules. So that is a very cool way to sort of like create instances of the same thing in a way that you can sort of like change it later. But you can also apply changes to the individual instances and make them different. In this case, I keep changing the color because it's the fastest way. Another thing that a prefab implies is that now this orb doesn't have to be in the scene. I can actually get rid of it. I can delete it, and my orb prefab is still here, ready to be used. I can double click it and change it. I'm actually gonna go back to the circle. I think I prefer the circle. So the prefab can behave like a game object, and I can basically do something like this. Say that I have a bullet prefab field, which is a public field of a game object. I can drag and drop my orb here and use this bullet prefab, this prefab here as my bullet. So instead of using the little tiny square, I can use this big orb. Will it behave like the bullet? No, because it doesn't have the same script attached, but it should be instantiated in the same way. So now I sort of like created a series of balls that, as you can see, are sort of like accelerating in an infinite way. This is almost like playing a Portal because they are being sort of like teleported back, but their speed keeps increasing, and so they kind of like get into this ridiculous endless loop, this sort of like physical paradox. But this is basically how a prefab works, and it's really one of the most important principles. Okay, I'm gonna get rid of this orb here. Just make sure that, be aware that when you're deleting a prefab, you're also deleting all the references to that prefab, and that's why it tells you, watch out, you cannot undo this action. In this case, I'm confident that I can delete it. But here's this is the main one of the main principle in game development, and in particular in Unity, just using a prefab as this kind of construct, this kind of class for a complex object, and then use it instantiate to create it. And I'm basically doing the same thing with the asteroids as well. And in order to split the asteroids, I'm sort of like doing the same thing. I'm sort of like creating a split and basically instantiating a clone of the same object, of its own clone. The instantiate action returns a value, which is a game object. So I can save, I can store my bullet into into an object, into a variable called new bullet of the type game object, and now the new bullet can be accessed. In this case, I'm actually not doing anything with this new bullet, but I think in the case of the asteroids, yeah, in the case of the asteroid, I'm sort of like instantiating a class of this asteroid class, and so I can immediately access and do things like setting the trajectory of the asteroids. In my case, I'm not doing anything with the bullet because I decided, as I anticipated before, I decided to have the force happening in the bullet itself. So the bullet will be propelled by itself, quote unquote. And I'm using an add force, and I'm also using a transform up. So I'm kind of like using the same principle as the spaceship, really. I'm adding a force in the direction, in the upward direction. So it's kind of important that the bullet is instantiated with the proper rotation. And in this case, the rotation, I'm basically passing the rotation of the player, so the spaceship. So transform rotation means, okay, apply the same rotation to the bullet itself. So even if the bullet doesn't seem like rotated in any particular direction because it's a tiny square, a pixel, it does have a rotation, and that's what defines its trajectory. So this is just one way to do it. And then I play a sound. There's also like a little thing that I'm doing here. I have like a little invulnerability timer here. Just to make sure that when your spaceship has been destroyed, it responds at the center of the screen at the coordinate 0, 0, and it is not destructible for a couple of seconds, so you can sort of like get out of the way and you don't get killed unfairly by an asteroid that just happens to be there. So this is just a variable that gets decreased by this time delta time. This just means do a countdown, essentially. Here's the other main thing, sort of like one of the main, most crucial things for games, especially like arcade games that are all about sort of like objects hitting other objects and objects sort of like colliding with other objects. And it's this function here, on collision enter 2D. This is a Unity function, so you can just like write it this way. In this case, it's private, but it doesn't matter. And this is a function that is being called automatically whenever something collides a rigid body object. A game object has a rigid body and a collider. So there are several conditions for this function to actually work, and they are the following. So in this case, we are still talking about the player. The player, if I zoom in, can have a sprite render or not. That's not super necessary for this, but it needs to have a rigid body in order to understand collisions, and it needs to have a collider. So the collider can come in different shapes. You can, if you don't like the square collider, let me kind of like get rid of sort of like this audio sources. But if you type collider, and again, we are talking about 2D, collider 2D, I can use a circle collider. I can make even like the collider much smaller to be like a little bit more forgiving in terms of collisions. But yeah, this area here will be the area that triggers a collision. So that's my condition essentially. I need a collider, I need a rigid body, but also I need another object with also a rigid body and a collider. I guess the collider can be a trigger. So maybe there are some situations in which maybe the rigid body is not completely necessary, but just to be sure, I would say add a rigid body every time. So the other object in this we are talking about in this case are the asteroids. So this asteroids here is also prefab, so they are getting basically created in the same way as the bullets, and similarly to the bullet, they have a little script and a collider and a rigid body 2D. So if these conditions are all in place, then you should be able to have this function that gets automatically triggered by a collision. Now, in Unity, like you get called, or like, collisions happen, you know, with any collider basically collides with any other collider. So this other thing you need to do is you have to essentially to figure out what hits you from the perspective of the player of the spaceship. You have to figure out what was the thing that triggered the collision. And there are a few ways to do so. I think the easiest and the more elegant way is to check the tags. So the tag is something that you find up here in the inspector in the tag drop-down menu. So you can create your own tag. You can create a whole bunch of, I think, infinite tags. Every object can have only one tag, and you can see here that there is an asteroid tag, a bullet tag, a boundary tag that was part of the original game that I started from, that I had to basically recode entirely. So like ignore that because there will be no boundary, but you can just create your tag, and like if you want to create, I don't know, like I'm gonna get rid of that. If you want to create like a bomb, which is a different type of you know, objects, you can yeah, you can create it, and then it becomes usable, and you can assign this different tag, right? So I think that this is kind of like a fun, easy way to classify basically your object. Let me get rid of this bomb tag. Next time I restart, those tags will disappear. So here's a way that you can sort of like check the tag. One way is to access the collision, and then a game object and compare tag. I think it's actually the same as doing like collision game object. Oops. Collision game object tag equals you know, asteroid or something like that. I don't know why that function was there, but yeah, it's essentially string comparison. So here, basically, what you get upon collision is a reference to the collider. So it's the collider that actually triggers the collision, not the object itself. But when you have a reference to a component like a collider, you are able to access to the game object by typing component, name of the component, game object. So basically, if you are here and you have like the sprite render, you always can get to the actual object, which is this whole thing that you see in the inspector, and you can get to the transform of it. So if you have access to one component, you can get to the game object. If you want to go from the game object to the component, you will have to use something like get component and this kind of a bit idiosyncratic syntax here. So here is starting from the game object, you get the rigid body, and here starting from, for example, the rigid body, you can get to the game object by accessing the property game object. Keep in mind that game object lowercase is different from the class game object with the uppercase, which can be used for other things like game object find or things like that. And thankfully it is highlighted in green. Anyway, so this just means, okay, you have a collision, that's the collision that hits you, the collision enters, so it's at the very beginning of the collision. You can also detect for as long as the collision lasts. There are like slightly different functions for that, but yeah, this basically this thing will return true if the object is tagged as asteroid. You can also do something like yeah, if it was like, for example, a versus game in which you have two spaceships, you could even do like something like this. Bullet. Like that. So if what collided is either an asteroid or a bullet, then you destroy the spaceship. So it's very, very flexible, very easy to just like add new features using tags. And here, what happens here is that I'm resetting the velocity, so I'm sort of like setting it to vector 30, which means just like zero all the components of the velocity. I'm resetting the angular velocity, so when it restarts, it doesn't inherit the previous the previous like speed. And then I'm calling a function on the game manager, telling the game manager, so the main brain of the game, hey, this player is dead, has been collided. So there's no energy here, so no energy bar. So as soon as you enter an asteroid, you die. And so like I decided to handle everything involving death from the perspective of the main game manager. So player death here. This is the function that gets called when you die. Now, a lot of these things could have been also handled from the player script. This is really at your discretion. There might be like pro and cons from doing certain things from the player versus the other. So one thing, for example, that I couldn't do from the player was play a sound, because what I'm doing when you die is I'm basically disabling the player. Set active false just means turn it off. The player is the equivalent of taking the player and unchecking this box here. Give it a second to load the stupid script. So set active just means the same as this. So basically, like the object is almost as if it was destroyed, but it's still there. So it can be reactivated. And that's kind of what I'm doing. I just wanted to show you a type of pattern that might make sense. I didn't destroy the object completely. I just disabled it for a few seconds, just to give the player a moment to think about mortality and death, and just sort of like reset the game situation. So yeah, here I do a bunch of things, like I subtract the number of life, and this is where I check the end condition and I trigger the game over if the lives are 0. So sort of like the action at this point, since the player is dead and is being turned off, the action moves to the game .cs, so like the game controller's game manager script. One other thing, here's another like useful function that a lot of students don't know it exists, but it sort of like saves you a lot of head scratching if you know how to use it, which is invoke. Invoke is basically calling a function after a delay. And it's very useful in this case. For example, I don't want to respawn the player immediately. I want to give the player a second to take a breath and realize that it's being, show the explosion and be like, okay, now take 2 seconds and you're starting and you're back into action. So in order to do so, I can call a function called spawn player, which is the reset of the player. And the second parameter is basically a number of seconds, that is the time to respawn. So spawn player, unfortunately, kind of like requires a string, the function name as a string. So we can go to spawn player here, and it's really not much. I'm just basically like resetting the position, setting the invulnerability variable to a variable that is respawn invulnerability, so it's whatever variable I put here. Default is 2, but it can be whatever you want. And then I set the game object as active. So I didn't destroy the game object. The player has always been in the scene, it's just has been made inactive. I could totally use the destroy in the same way I'm destroying asteroids and bullets, and then reinstantiate. I just wanted to show you a different approach to that. All right, I'm gonna end here, like for the chapter that regards the player, and in the next episode I'm gonna talk about everything else that is not the player.